Up to now, highly viscous products always posed a challenge when it came to inspection, since a reliable detection of particles with the common inspection method works only for liquid products. Conventional camera inspection identifies particles in liquid product on the basis of changes in position. Stationary markings, scratches, or contamination on the outside of the container can therefore be clearly differentiated from particles inside the container. The rapid rotation of the container displaces the liquid and sets any particles in motion. When the rotation of the container is stopped abruptly, liquid and particles remain in motion. Markings, scratches, and contamination on the outside, however, are no longer moving. A camera takes several images. These are compared with each other. Everything which is not moved is masked and deleted from the resulting image. What remains are the differences between the images, i.e. the objects which have changed their position from one image to another. In the case of highly viscous products, however, the described inspection method produces no result, since the contents of the container cannot be set in motion by rotation. Since there are no changes of position of the particles between the images, impurities inside the container cannot be differentiated from those on the outside. Now, Seidenadder's revolutionary 3D inspection also enables detection of particles in highly viscous products, such as hyaluronic acid. The conventional inspection method is extended to a third dimension. Highly accurate handling, the interaction of high-resolution cameras, and innovative computation methods enable identification of particles in highly viscous products. In the first stage for 3D inspection, the camera takes a first image. To be able to differentiate between particles inside and outside the container, two virtual images are generated. It is assumed that all particles which are visible in the real image are outside on the back surface of the container. A calculation is now carried out to see how the image would look after rotation by a defined angle. In the next stage, it is assumed that all particles from the real camera image are on the front surface of the container. After the same defined rotation, the image would look like the generated virtual image of the front surface. Now the container is actually moved by the defined angle, and a second real camera image is taken. This is compared with the two virtual images. If a particle on the camera image matches with a particle from one of the virtual images, the assumption that the particle was on the outside surface of the container is correct, and the particle is masked. The stages described above are repeated until the entire circumference of the container has been inspected. In the resulting image, only unmasked particles are shown, i.e. those which have been identified as definitely inside the container by the process of elimination. Seidenadder 3D inspection, the solution for particle detection in highly viscous products.